friends, welcome to Devrat Knowledge Villa. You are watching our English video series of operating system and learning deadlock. Today's our topic is Banker's algorithm for resource request. Actually, we are learning Banker's algorithm as a part of deadlock avoidance techniques. There are basically three techniques for deadlock avoidance. First one is safe state, second one is resource allocation graph, and third one is Banker's algorithm. We have already discussed above two techniques, safe state and resource allocation graph, in our earlier video. So guys, today's our topic is Banker's algorithm. Basically, two algorithms are there. First algorithm is for the resource request and second algorithm is for the safety purpose. So we will discuss both the algorithm one by one. First, start with the resource request. Before today, we have discussed one example to define the safe state and unsafe state. So guys, if you are still remain to watch this video, so please click on I button at top right corner and watch that video and come back to here, because this example is very useful to understand today's algorithm. Let's start with the first step. This both pictures will be available to better understanding for the Banker's algorithm. First, we will define the data structures are used in Banker's algorithm. Get it? So there are basically four data structures are going to be used for the Banker's algorithm. Before that, we will initialize our n with the number of processes. It means in our discussions, n will represent the number of processes as well as m will represent resource types. Get it? So in our whole discussion for the Banker's algorithm, we will represent processes with the n and we will present resource type with the m. So let's see. First thing, that is available m is equal to available I is equal to k. Now thing is that m is for the resources. It means number of available resources is number of instances of k type is available for the process I. K is representing number of instances of resource type m. Get it? And I is representing the process number like P0, P1, P2. Get it? So k number of instance type of resource type m are available for the process I. Get it? Let's see here into the table, total 3 number of resources are available for the process P0, P1 and P2. So we can say that for the P0, P1 and P2 total 3 instances of resource type M are available. Let's see next. Maximum n cross m is for maximum I of j is equal to k. So j is representing the resource number here. Get it? M is for the resource type, j will represent the number of resource and k is represent the instance of resources. Now n cross m means this maximum value is in form of matrix. Here n represent the number of rows which is indicated by the processes and m will represent number of columns which is represented by resource type. So how many maximum resources are available? So if you will look here, total 12 number of resources were available at that time whenever we have discussed the example of safe state. So we have discussed it by the total 12 number of resources up to R0 to R11. Get it? So thing is that total maximum resources available at that time there were 12. Get it? Now let's see next. Next thing is allocation n cross m for the allocation ij is equal to k. So again, how many resources are going to be allocated? So here you can see into the allocation table for the process P0, total 5 resources are allocated to process P0. It means here we can say that for the I representing process number, for the process P0, total 5 number of instances allocated to resource type M to process P0 and whatever the number of resources are there, like R1, R2, R3, R4, whatever, it is indicated by the J. Get it? Hope you are understanding. If you are any doubts or query, you can make me comment on comment box. Next thing, that is need n cross m, need ij is equal to k. So what need is representing, after allocation, again there is a few needs of process, like there is a maximum need was 10. Get it? But out of 10, 5 resources are already allocated. So currently 5 more resources are required. Get it? So till process P0 need 5 instances of resource M for the any type, whatever it should be, R2, R3, R4, whatever. Get it? So here, hope you are understanding what is represented by the available, maximum, allocation and need. Get it? So it is the maximum need, it is current need, and these are the total number of availability. Get it? Let's see with the algorithm. If we will look about the algorithm, so first step for the resource request algorithm, that is, if request I less than equal to need I, go to step 2. It means request should be less than or equal to need. Let's see here, whenever process will start its execution, so before starting the execution, process already claimed their required resources. Get it? And whenever during the execution, when process will require, so at that time process will make a request for those number of resources. But how many resources a process can request? That is the fundamental. Request less than equal to need. It means process can request number of resources less than or equal to need. It means process cannot be request more than number of greater number as per the need. Suppose P0's need is 5. Get it? So maximum resource process P0 can request 5. Get it? So it means process P0 can request less than or equal to 5. Process P0 cannot make a request more than 5 resources. Get it? If request should be less than or equal to need, then go to step 2. Otherwise, raise an error condition since the process has exceeded its maximum claim. It means process is requesting more than its claimed. Get it? So this thing will not be available. It will lead to a deadlock. Get it? So process can request less than claimed, not more than claimed. Get it? Now, next step, that is request I less than equal to available. It means number of process I means whatever, it should be P0, P1, P2. Available means total available. That's why I is not going to be indicated with the available. Here if you will see, so for the request and need, it is indicated with the I. It means process number. Availability is a total availability for entire state or system. Get it? So request I less than equal to available. Wherever request less than equal to available, then go to step 3. It means in these cases only request can be fulfilled. If you will look like request less than equal to available, look like P0 require 5 number of resources. Suppose P0 will put a request for the 5 resources. So it is possible to fulfill? No, because only 3 resources are available. So P0 have to request maximum 3. P0 cannot request more than 3. What happens if it requests more than 3? Then otherwise Pi must wait since the resources are not available. It means if process P0 request for the 5 resources, so it should not be allocated. Process P0 have to wait till the 5 resources available. Then and then 5 resources will be allocated to process P0. Otherwise not. Get it? So request less than equal to available. Suppose process P0 requesting 3 resources, then it will goes to step number 3. Get it? Now let's see what is in step number 3, that is available is equal to available minus request I. Available is a total resources, as we know total 3 resources are available. So what will be the next available? Available minus request. For example, look, now we will consider for the process P1. Suppose P1 requires 2 resources, get it, and P1 requesting for the 2 resources. So what happened? 3 resources were available. Out of 3, 2 resources allocated to process P1. Get it? Total available resources were 3 minus requested 2. So how many resources will remain here? Total remaining resources are 1. It means new available resources are 1. So hope you are understanding this line. Available is equal to available minus request. Next line, allocation is equal to allocation plus request. It means after allocating a new, what will be the new allocation? In previous moment, if we will look about the P1, so 2 resources were already allocated, and now we are allocating 2 more requests, 2 more resources. Get it? So what will be the total available? 2 plus 2. Get it? It means already 2 resources were allocated and plus 2 resources more requested by process P1. Get it? It means allocation will be total 4. 2 plus 2 is equal to 4. It means total 4 resources allocated to process P1. Hope you are understanding this second line also. Next line, need I is equal to need I minus request. What was the current need before the moment? That was 2. But after allocation, that process P1 requested 2 more resources. Get it? So what will be the new need? New need will become 0 because 2 resources were allocated and then after 2 more resources are allocated to process P1. Get it? So new need will be 2 was a previous need. As per the need, total 2 resources requested. So what will be the new need? New need will become 0. So now there is no more resources required by process P1. After this allocation, P1 will execute completely. That's why we got at that time there is a safe state. So hope you are understanding all these 3 lines. If you have any doubt, you can comment me on comment box. Let's see now what we have to check, that is step number 4. Check if this new state is safe. We have to check for the safe state. Get it? Suppose P1 will be executed and P1 will complete their execution. So similarly P0 also have to complete its execution, as well as P2 have to completely execute. Then and then we can say that this state is safe. So we have to check for the whole number of processes. So to do this checklist, we have invented one more algorithm, that is Banker's algorithm for safe state. Get it? Let's see. It is our algorithm for the safety. So whatever we discussed today, hope you are understanding very well. We will discuss this safety algorithm in our next session. Thanks for watching Devrat Knowledge Villa. Thank you very much.